All right, so the process for creating an inverse, right? Let's take just a quick recap of where we've been. We talked about how a function can and its inverse can be thought of as flipping the x and y values. Okay, we talked about how graphically, and that's if we're looking at a table of values or possibly like a set of ordered pairs, right? We just flip the x and the y coordinates, and we get the coordinates of a point on the inverse. We talked about how a graph of a function could be reflected over this identity line, and then we get the graph of its inverse, right? We talked about only functions that are one-to-one can even be thought of to have an inverse, okay? And we test for one-to-one by using the horizontal line test. The one thing we haven't looked at is how do we actually create the function notation for an inverse, right? And it's really a four-step process, but with one of those steps having multiple different steps. But let's take a look, okay? So here's our four steps for creating an inverse, and then we'll work through an example here as we go through. So step number one, because you're going to be given the function in function notation, right? And I don't want to make this too granular or too specific, but I think you'll want to replace the f of x with y. Right? That's simple because f of x is the same as the y coordinate, right? Then you want to swap the x and the y's. So everywhere you see the x over here, you're going to turn every x into a y, right? And one thing you want to keep in mind is that when we talked about inverses before, we said that an inverse is an undoing, all right? Think of it this way. So when you look at this function f, what does the function f do to x, right? It multiplies it by 3 and then it subtracts 7. So we want to undo those operations, right? How do you undo subtraction? How do you undo multiplication? That's what we're going to do, okay? We start that process by swapping the x and the y, and then we solve for y. And this is what I meant before when I said there's multiple steps here. So we're solving this equation for y. We want to end up with a statement that says y equals. So if I was solving for y, the first thing I do is add 7, right? 7 is the inverse operation of subtraction. So now my statement says x plus 7 equals 3y, right? And then to solve for y, I would divide by 3, which means I'm going to divide everything over here by 3. And we end up with y equals x plus 7 over 3. All right. So there's me solving for y, done. And then the last thing is sort of a bookkeeping step and not necessarily something you have to do. But because we were finding an inverse function, I replaced the y at the end with the inverse function of f notation. That's it. I don't change the actual function. I just change the way that I express it. Okay. So again, remember that finding the inverse of a function is undoing these operations. Right? So if I need to undo subtraction and I need to undo multiplication, then in the inverse operation, I should have addition, which is the inverse of subtraction, and division, which is the inverse of multiplication. That's how I know I'm probably pretty correct with that.